Hi everyone, this is coming to you from Education for All. We are looking at part B of this question here. Part B says 1 minus 2 sine square 25 degrees. 1 minus 2 sine square 25 degrees. The B part says 1 minus 2 sine square 25 degrees. We're asked to express this function here as a single trigonometric ratio. So, how we go about this? Now, looking at this, you have 1 minus sine square 25. So, which means we need something about this sine square here from our trigonometric or from our double angle formula. Correct? Now, where do you get sine square from? How do you get sine square from these trigonometric identities? Where do you get square? When you say the first one, if you say sine A plus B, you're going to get sine A cos B plus cos B sine A. Yeah, there is no square there, even if you say A equals B. But you can see that for the cosines, if you say the cosine, excuse me, of A plus B, this gives you the cosine of A times the cosine of B minus the sine of A times the sine of B. Why do we choose this? We have chosen this formula because of this square. We see sine square here. Mind you, we are looking at double angle formula. We know that this one will give us sine square here if we assume A is equals to B. Then if A is equals to B, then we'll have the cosine of 2A. And here, since A is equals to B, we'll have sine A, sine A. So that sine A times sine A will give you sine square A, because we see sine square here. So we are using this double angle formula to get sine square from somewhere. That is the technique we are applying here. So now if we say A equals to B, this one will give us the cosine of A plus A. We are assuming A is equals to B. So this will be now the cos of A times the cosine of A again minus the sine of A times the sine of A. Excuse me. So this boils down to cosine of 2A is equals to cos A times cos A. This gives you cosine of cos squared A minus this one gives you sine squared A. This is what you get. So now we have this here. But again, we want to have sine square A here. We still have the cosine A, cosine 2A, cosine square. We want to do something. We now want to do something very, very important. You know that from your right angle triangle, This is ABC. This is ABC. Yeah? Adjacent, opposite, hypotenuse. If I say I want to apply the trig functions here, I'll have sine of A is equals to opposite all over hypotenuse. The cosine of A adjacent all over hypotenuse. Correct? This is what we have here. We also know that C squared is equals to A squared plus B squared. Hypotenuse using Pythagoras theorem. Right? These are things we know. What am I trying to do? If I divide this by C squared, I divide this by C squared, I divide this by C squared, divide everything by C squared. It doesn't change the equation because I'm dividing a particular number throughout the elements in the function. So it doesn't change anything. I'm dividing C squared throughout function. So C squared divided by C squared, this will give me 1 is equals to A squared over C squared. This will be A all over C all squared plus B squared over C squared. This will be B all over C all squared. You get that? You are squaring this, so you can square both of them at the same time. But what is A over C? A over C, we have it here to be cosine of A. So therefore, this will give us 1 equals to the cosine squared of A, because we are squaring A over C, cosine of A, plus B over C. What is B over C? Sine squared of A. I'm assuming that you know this, that cos square theta plus sine square theta is equals to 1. Cos square A plus B square A is equals to 1. Cos square P plus sine square P is equals to 1. This is fundamental in mathematics. You know this. I just derive it for you here to see how it comes about. So now we know 1 is equals to cos square I plus sine square A. Now we want to use that one. Forget now about all this. All this. 1. Get rid of this. So we know that from here, we want to get rid of this cos squared because our problem is talking about sine square. So we want to get rid of this cos square. So this cos squared, from here, you will now have cos squared A from this formula. This will give you 1 minus sine squared A. You know that. So this problem now becomes, instead of cos squared, here we'll have 1 minus sine squared A minus sine squared A. Correct? If that is the case, we now have this to give us 1 minus sine squared A minus sine squared A. You know there's a 1 here, 1 here. So this will give us 2 sine squared A. You see that? 1 minus 2 sine squared A. So now we have our, here A is 25. A is 25 is given here. What is different here? A is 25. So if the A is 25, this will give us 2 sine squared. A is 25. So for here, where we see A, we put 25, the cosine of 2A times 25. A is 25. Now here, A is 25 degrees. So cos 2 times 25, this gives us the cosine of 50 degrees is equals to 1 minus 2 sine square 25. So our answer is cos 50 degrees. This one, our answer is cos 50 degrees. Thank you for watching. Bye-bye.